keeping it rational and a little irrational with Mr. Winstead. Alright, today we're going to be talking about a very important topic because it's a topic that you'll use for the rest of your life. And it's solving 1 and 2 step equations. But before we can jump in and just start solving, we need to know a few definitions. And the first thing is, what is an operation? Well, an operation is something you've been using forever, and it's addition, subtraction, multiplication, and division. Now, we're going to be mainly using inverse operations. And an inverse operation is just an operation that undoes the other operation. So, for example, addition undoes subtraction because subtraction is the opposite of addition. So, that means subtraction undoes addition, division undoes multiplication, and multiplication undoes division. So, you can see that each one of these here are just opposites. So, it's very important. The next thing we need to talk about is the golden rule of algebra. And it's something that you must know and must be able to apply to solve these problems. And what it is whatever you do to one side of the equal sign, you must do to the other side of the equal sign. So if I subtract on one side, I have to subtract on the other, add on one side, add on the other, and so forth. So let's get to actually solving a few of these examples. So the first one we're going to look at here is x plus 7 equals 4. So the goal into solving these is to get the x alone on this one side of the equation. So the first thing I'm going to do is I'm going to draw a line right down the equal sign, and that separates my left side and my right side of my equation. So like I said, the goal here is to get x by itself. So I'm going to put a little box around it. So I want it by itself. So how do we do that? Well, first we have to recognize what we have with our x. And I have a plus 7 with my x. So, since I have a plus 7, to get rid of it, I have to do its inverse operation. So what we said, subtraction was the inverse of addition. So if I subtract 7 on both sides, now remember that's the golden rule, if I just subtract 7 on this side, I subtract 7 on this side, what happens is 7 minus 7 is 0, so they just go away and leaves me with an x all by itself. And that was our goal. So 4 minus 7 is negative 3. So since we have x by itself on this side, we've reached our goal. And our solution should be negative 3. And the reason I say should be is because we need to check. And that's something we often forget. So make sure you check. So to check, we plug in what we think our solution is back in for x up here. So I have negative 3. Plus 7 equals 4. Negative 3 plus 7 is 4. So 4 equals 4, so that checks, so that is a good solution. Alright, let's try another one real fast. So again, first step is I'm going to draw a line right down our equal sign. That way it separates my two equations. So again, we want to get x by itself on one side of the equation. So I need to recognize what is with my x. In this case it's a minus 5. So I see subtraction is my operation, so to get rid of this minus 5 I need to do the inverse operation. So we said subtraction, addition is the opposite of subtraction, so if we add 5 on both sides, that's the golden rule, take that away, and that leaves me with x equals 8. And again, check to make sure. So we think that's our solution, but we need to check it. So we plug in 8 back here. So 8 minus 5 equals 3. 8 minus 5 is 3. So 3 equals 3, so that checks. So that is my solution. Alright, so far we've worked with addition and subtraction and their inverses. So now let's work with another one. Okay, so on our last examples we did addition and subtraction. Now you look at both of these examples and you do not see any addition, subtraction for us to get rid of. So I'm going to start this problem off the same way as I did the others. Let's draw a line, separating our equation on the left and the right. So we want to get x by itself. So I'm going to circle it or box it in real fast. So looking at this right here, how do I get rid of it? I want to get rid of this negative 6, but how? So you look, it's negative 6 times x, because this is understood to be multiplication. So earlier we said to get rid of multiplication we needed to divide. So if I divide negative 6 on both sides, these cancel, leaves me with the x by itself, which is what we want. 48 divided by negative 6 is negative 8. Alright? So, we think this is our solution, but first, before we do that, we need to check. Never forget to check. So, we take this negative 8 that we think is our solution and plug it back in. So, negative 6 times negative 8 equals 48. Negative 6 times negative 8, and negative times negative is obviously a positive. So 6 times 8 is 48. So 48 equals 48, so this is a good solution. So same thing with this next one. We start off, make our line. Alright, we want to get W by itself. So, again, this is 6 times W, so that means we need to divide. So 6 and 6, that cancels, leaves me with a W equals. Alright, negative 54 divided by 6 is a negative 9. So again, we check. So plug in negative 9 here. So 6 times negative 9 equals negative 54. And you can plug that in the calculator and double check this, but that does check. And that is a good solution. Alright, this is our fifth and sixth, which is our final examples for single or one-step equations. Now look at this equation, and I know what you're saying. Mr. Winstead, man, it's fractions. I hate fractions. But guess what? I'm going to show you how to do this very, very easily. So, again, let's draw our line, separate our equation. So you see this fraction here, right? First thing we want to do is get x by itself. But you're like, man, I don't know how to get rid of this negative 2/7. Well, it's a very special thing we call multiplying by the reciprocal. And all we need to do is take the 2/7 and flip it. Alright? So I'm going to take the 2/7 and I'm going to flip it. And that's still negative, times negative 2/7 x equals, what we do on one side, we must do to the other. And guess what? This cancels. And it leaves me with x. Multiply that out, you can use your calculator or do it by hand. When you multiply it out, you get negative 14. So you see how easy it was to clear the fraction? So all we have to do is take and flip it, multiply both sides by the flipped fraction, we call it multiplying by the reciprocal, and we get our answer. So it's a lot easier than it looks. So let's look over here at this one. Let's try one more. Let's draw a line. And hopefully you can see what the reciprocal is now. So we have 2/3. So we flip it and get 3/2 times 2/3 p equals 14 times 3/2. That cancels, leaves me with a p equals, when you multiply that out, you get 21. Now, what did we forget to do? We need to check these. Okay, so you need to check these. So we plug in our negative 14 back up here. So negative 2. Alright, once you get all that multiplied out, 4 equals 4, and that checks. And same thing over here. You take, plug the 21 in, so 2/3 times 21 equals 14. So 2 times 21 is 42. 42 divided by 3 is 14. And that's what we're looking for, so that's a good solution. So this right here is how you do one-step equations. Now it's time to learn about two-step equations. Now it's time to learn about the Alright, but seriously, we're going to learn about two-step equations. So the two steps of the two-step equations are as follows. So step 1, we either use addition or subtraction to get the term with the variable by itself on one side of the equation. So you're going to have two things on one side, so you need to move one away and get the one with the term alone by itself. Once we do that, we move on to step 2. It's use either multiplication or division to get the variable all alone on one side of the equation. So up here, we get the variable and the term alone. Then down here, we take and get the variable by itself. So our goal is to get the variable all alone on one side of the equation. So let's do a couple of examples and show you how to do this. Alright, so I got a couple of examples written down for us. So our goal again is to get this x all alone. So step 1 says to use addition or subtraction to get the term with the variable alone. So we want to get this right here all alone first, the whole thing. So I'm going to draw me a line down through the middle. So we need to get rid of this plus 5. So I recognize that the operation is addition, so it's a plus 5. So how do we get rid of that? By using its inverse, which is minus 5. So when I do that, those cancel. It leaves me with x over 2 all alone. 11 minus 5 is 6. Now, that was step 1. Step 2 is to get x all by itself. So to do that, we have to recognize what operation we have here. We have x divided by 2. So to get rid of a division, we have to do its inverse, which is multiplication. So if I multiply by 2 on both sides, this goes away. Leaves me with x equals 12. Alright, so we think our solution is equal as 12, so let's check that. So again, we plug this back in. So we get 12 over 2 plus 5 equals 11. So 12 divided by 2, use your order of operations, division first, is 6. So 6 plus 5 equals 11. 6 plus 5 is 11, so 11 equals 11, so that checks. So that means that is our solution. Alright, let's move over here to the second one. Let's draw our line. Now this right here might look a little funny because our variable's on the right hand side, but that's okay, we do exactly the same thing. So, step 1 was to use addition or subtraction to get rid of what's not with the term, or the variable, the term and the variable. So, here's our z. This is what we want to get alone, eventually, but in step 1, this is what we want. We want this right here to be alone on the right side of the equation. So I recognize that this is minus 7, that we need to do the inverse operation. So minus 7, the inverse of that is a plus 7. So do it on both sides. That gives you 6. Negative 1 plus 7 is 6. That goes away, and it leaves me with z over 3. Now, we need to get z alone. So z divided by 3, that's division. The inverse of that is multiplication. So if I multiply by 3 on both sides, I get 18 equals z. Again, check. So our check. We think the solution is 18, so we plug in 18 for z. So negative 1 equals 18 divided by 3 minus 7. Well, 18 divided by 3 is 6 minus 7. 6 minus 7 is negative 1, and that's what we want. So that is our solution. Alright, these are our last two examples. So, again, it's a two-step equation. So, our goal is to get x by itself. So, step 1 was to use our inverse operations to get rid of everything but this. We want the term and the variable to be left on the side, one side of the equation. So, we need to move this plus 9. By now, hopefully we understand that plus 9, the inverse of that is minus 9. So, we take on both sides, we get 5x equals 24 minus 9 is 15. Alright, so now, that was step 1. Step 2 is to get x by itself. So we need to get rid of this 5. So 5 times x equals 15. So, the opposite of multiplication is division. So if we divide both sides by 5, we get x equals 15 divided by 5 is 3. So we think that's our solution. So let's check and see. If it checks out, then it is. So we take that, plug it back in there. So 5 times 3 plus 9 equals 24. So here's a good way to make sure that you remember your order of operations. So you always do multiplication first, so it's 15 plus 9 equals 24. 15 plus 9 is 24. So 24 equals 24, so that is our solution. Alright, so our last example is 4y minus 4 equals 16. So we want, our end goal is to get this by itself, but again, step 1 said we need to use addition and subtraction to get rid of the term that does not have the variable. So this right here, sorry, erase my subtraction, is what we want alone after step 1. So we have a minus 4, so the inverse of that would be plus 4. So we add 4 to both sides. That cancels, leaves me with the 4y equals 20. Alright, now we did step 1. Step 2 is to get y by itself. So 4 times y equals 20. So 4 is being multiplied by y. So if I use the inverse, which is divide by 4, that goes away, leaves me with y equals 5. Last thing is to check. So you plug this back in. So 4 times 5 minus 4 equals 16. That's 20 minus 4 equals 16. 16 equals 16, so that checks. Alright, so that was our last example. I hope you learned something how to solve 1 and 2 step equations, because we will be using this right here for the rest of the unit, as well as the rest through Algebra 1. So thank you for joining me, and I'll see you next time.